This talk is about JobRunner, and for the people who are wondering what JobRunner is about, it's an easy way to perform backend process in Java. It's distributed and of course backed by persistent storage. So now everybody here knows if the talk is something for you. So small agenda. I will try to go fast through the slides as I want to do some live coding. Who am I? How JobRunner started? And then of course we're all developers. Talk is cheap. We want to see code. I'll discuss and show the internals of JobRunner. We'll talk about a little bit about the future, and then the live coding section where I will be eating my own dog food, and then I'm of course available for Q&A in the spatial chat joy room. So who am I? I'm a developer and tinkerer, father of 3 wonderful kids. The people from Comfy made this awesome avatar for me. That's also really nice. Thank you for that. I'm an Home Assistant fan, living in Belgium, creator of JobRunner, and of course a beer lover. So I was definitely born in the right country in Belgium, as we have a lot of beers. So how it all started, it was a couple of years ago that 4 years ago, I went on to I worked on a pre-sales project when I was doing consultancy, and we won the project, but for the customer, it was really important to have the code in .NET. And I must confess, I switched to the dark side. I learned myself a little bit of .NET. And in fact, it's not so bad. It's just like Java, but with more uppercases. And for that customer, we needed to calculate the wages based on historical data going back to 1950, which was provided by the Belgian government. So we had a lot of data. And to calculate all these wages, we found a tool called Hangfire in .NET. And for me, this felt really, really nice. It was easy to use. It worked great. And one of the quotes was, one day I will port Hangfire to Java. And then, a year ago, I got a new assignment. It was a greenfield project in FinTech. Greenfield is relative because they were already working on it for a year, and it was all related about e-invoicing. So the application we developed was middleware. It was a gateway to the PayPal network. And what is the PayPal network? To say it in one word, is a European standard for transmitting invoices from consumer to the guy who has to pay. And it was a microservice party, so there were a lot of RESTful microservices running on GCP, Google Cloud, and it was an asynchronous API. So the first call saved the document on disk, and then afterwards a pub/sub message was was transmitted, and the call returned to the customer. So they knew that we received the document, but processing still needed to be done. And once we started processing, everything was done synchronous using RESTful APIs. The goal was to process millions of documents per day. That's why they all went for microservices full on. But it was still new. We only processed a couple of thousand documents per month, and we didn't have that many customers in production yet. But there was a great CI/CD pipeline. But soon I noticed that processing was not retired on failure. That's of course possible with GCP, but due to time constraints, the developers didn't get to it yet. There was no monitoring. We did logging, but we did not have a correlation ID yet. And sometimes, invoices got lost, so that's not very nice. And I felt like the person on the picture there, the code was laughing at us, and we were sad, and I felt like, I got into some not so greenfield project, and time to turn on my cardboard for another job. But no, we started looking into other solutions, and yeah, for processing, there's a lot of stuff. All the cloud providers have some stuff, but it's always vendor specific. They require often extra infrastructure like Apache Kafka, Apache Hadoop, and there wasn't an open source one-stop shop that is easy to use, distributed, that can use all the existing infrastructure, includes monitoring, and where you can retry failed jobs automatically. So that's when I thought again to hang fire from the .NET world, and I started porting it, but doing the same in Java. And I wanted it to be as easy as possible for developers. So it's really simple. You can just use a lambda. It's distributed. It's embeddable. You just add it to your existing application. It uses all the existing infrastructure, and you have retries automatically, monitoring also included. So that's why I say, why isn't programming, distributed programming, why should it not be harder than this? It's just a lambda where you provide a method call. In this case, we just print something, and there's not more to it. And of course, it comes with a complete dashboard. How that's all done, I will show you later on. But at least we now had monitoring, and if jobs fail, we see it, we can act on it, and voila. So, like we are all developers and talk is cheap, we want to see code. So I'll give you all the possibilities you can do with JobRunr, and then let's see. Afterwards, we will do it all live. So here we enqueue a really simple job. My service can be any service that you have in. I'm still old school. I'm doing a lot of Spring related stuff where we have our beans and we call methods on our service beans. But JobRunr is of course also tested against Quarkus, against I'm even working on GraalVM. And so if you want to enqueue a job, it's just passing the lambda. It's up to you. You get back the job ID if you want to keep it or not. Using the job ID, you can cancel the job if it's not started, or even if it started, you can cancel it. And people who like to work test driven, they saw, hey, but that background job class, yeah, that's a static class. That's difficult to test. Well, it's just a facade for readability. You don't have to use it. There is, of course, a job scheduler bean where you can just enqueue, you can inject, and you can use that one with all the same methods. Sometimes you want to run jobs for a whole lot of data for all your users in your database, for example. So let's say you have a user repository, you put a method on it which returns all the users. And the nice thing is that, for example, Spring, it gives you a stream of users. And that's great because JobRunner also accepts a stream, and then for each item in that stream, we can do something. So here it's the example, the user stream we pass as the first argument, and then for each item in each user in that user stream, we can, for example, send a certain mail with a certain template and send that to the user completely in the background. And of course, sometimes you want to only schedule work a couple of hours after a user registered, or you want to do it at certain moments. So this schedule method, which is also available on the job scheduler service, allows you to schedule any method using either an instant or a local date time, an offset date time. And that way you can schedule dates not dates, but methods in the future. And if you want to do some recurring stuff, like for calculating the wages, we needed to process that data every hour. So there is a schedule recurringly method, which takes in, again, a lambda, and where you can just pass a cron expression. Here there is a some extra methods for readability, cron.daily, but you can just pass any cron expression to run the specified lambda at certain times. And for the recurring jobs, of course, it's also visible in the dashboard. And if you want to start it faster, you just select it, trigger it, you can delete it. The dashboard really helps at certain moments. And things can go wrong, of course. So let's say we need to consume other web services which are not in our control. Then in that case, the web service can fail, and if it fails, yeah, our service will fail. So all that is also visible in the dashboard, and it will be automatically retried up to 10 times with exponential backoff policy. So you don't need to do anything for it. If you want to have not do it 10 times, but only 2 times, for example, you can do that easily with a job annotation where you also can specify the name which will be visible in the dashboard and the number of retries that you want. But 10 is the default. So that was the part about where we see the methods, how you can use JobRunner, and I'll also want to explain the internals of JobRunner. So how is this magic going on? Well, let's first go to the architecture. So what we typically do is in our web server or web API layer, or REST layer, we get a certain HTTP call, a REST API call. And what we do is we first create a job, and after that it returns immediately to the caller. And while we create a job, the job is saved into the storage system. This can be a SQL database or a NoSQL database. And then what happens, there are 1 to n background job servers which look into the storage systems if there are new jobs to perform. They take them using optimistic locking, and then they start performing the job. And when all is well, or if it's bad, the job state is updated again in the storage system and rescheduled if it's failed, for example. So how does JobRunner does it magic? Well, JobRunner has one dependency on ASM. ASM is a library that allows to read class files, and that allows me, helped me a lot with writing the internals of JobRunner. So for example, when you enqueue a certain background job method, behind what happens in the class file is this code. And there is something important here. That's the invoke virtual statement. The invoke virtual statement, in fact, that's the statement, that's the actual lambda which we want to invoke. And what JobRunner does is, in fact, it reads these lines, and using that, I collect all the necessary information, including parameters that you want to pass along to your service methods, and this allows me to do it. Here again, the invoke virtual, it specifies that we want to call the do work method on the test service class, and the stuff in the class file, so in the bytecode here, the Java string, Java time instant, and an integer, it matches completely this. So it's not too difficult to find out in a class file what exactly the user wanted to call. And then the question, isn't this dangerous? Well, I promoted my library a little bit on Reddit, and this was feedback that I got. So it may be nice at first glance, but there's so much black magic going on that should just never be relied upon. Well, I don't know if I 100% agree with that, because this is part of the Java language specification. And for example, a lot of other languages also compile to the same class file, which is really specified. So that's why I don't think it's that dangerous. On top of that, Oracle reached out to me a couple of months ago, and JobRunner now takes part in the Oracle Quality Outreach program. The guys are really helpful. They send me an email when there is something new on the OpenJDK, and they ask, hey, can you test against it? That way they find bugs early, and I'm still sure that it works on the newer JDKs, and it works on every JDK from 8 to 16, and it also works with records, for example, so I'm quite comfortable with that. And last but not least, using the excellent test containers framework, I make sure that every time the CI/CD pipeline of JobRunner runs, I test against all the latest, all these different JVMs, Zulu, Adopte OpenJDK, just to make sure that if you guys are using JobRunner, I don't break anything by chance. So in my eyes, this isn't too big of a risk. So this was the part where we analyzed the lambda. Then what happens with all the information that I collected, I convert that to the JSON. And in this JSON, it specifies which class you want to run, which method you want to run, and all the parameters. How do I get the parameters? Well, they are in fact all serialized to using either faster XML, so Jackson, or any BSON compliant library. JSON is also supported. So this is all just converted to JSON, and then this JSON is in fact stored in a relational database or in a NoSQL, like Amazon Document DB, Elasticsearch, or all the other major SQL servers out there. Once it's saved in the your storage provider of choice, the background job servers, in fact, they read from the database, and one of the things that happens is it checks for enqueued jobs. So when it starts looking for, is there any new work available, first thing to do is how much work can this background job server take on, because we don't want to exhaust it, of course. Let's say you have 1 million of jobs waiting. The server only has a couple of thousand threads, for example, then by default it will only take the 1,000 threads. It will not exhaust a complete thread pool. And when it can onboard new work, then it will get all the enqueued jobs from the database, and we start giving them to the background job server to process them. And what is the first thing we then do? We update our domain. We say, hey, you start that job, you start processing on a certain background job server, and then we save it. And here is where the distributed part comes in. So when the job is being saved, there is some optimistic locking going on, and the first server that can actually save the job with the process state is the one that can actually process the job. So let's say we have 10 servers running, and there are a couple of jobs available. The JobRunner tries to be smart and gets a certain number of jobs from the database, and the first thing it does, it will try to put the state into processing. When that succeeds, only the processing will start. If not, if we have a concurrent job modification exception, well, this means that the processing already started on another server, and we don't need to do anything. Then we process the actual job. This is rather easy. This is just some reflection going on. We get a job to perform. I ask it from the IOC container. Then we get the job method to perform from the JSON, and then we invoke the actual method with the correct parameters. And then we store, of course, the job outcome when it succeeds or when it fails. And by default, JobRunner will also be do self cleanup. So job that succeeded will be automatically deleted after a certain amount of time. Voila. These were the JobRunner internals. So then what's going on? What am I working on? GraalVM native support. There is already a small proof of concept working with Quarkus. And there are some other features that people are asking for on GitHub, like authentication, searching for jobs, and migrating of jobs that are scheduled but did not run yet. Voila, and then I think it's time to eat my own dog food and do some live coding. Let's see, I still have 10 minutes available. So I think that should be possible in 10 minutes. Let me start a new project. And it will be Java 11. I'm using Maven. You can choose whatever you want, Gradle, Maven. And I don't know, my laptop is a little bit slow for the moment. It's really slow. Okay, let's go for it. Let's call the project JobRunner example. I want to open it in a new window. And I hope IntelliJ will work along. Okay. Let me maximize the screen. I already prepared the POM a little bit. I'll quickly go through it with you guys. So what are we going to do? For the POM, we depend on the Spring Boot starter, and we use the Spring Boot starter web. I also add the JobRunner Spring Boot starter, and for this demo, we will use PostgreSQL. So let's refresh so that we have all the dependencies available. Okay. And then let's start. I want a new class, so this will be org.jobrunner.example.sample application in this case. And this is a Spring Boot application. And we need to start this application, of course. So let's say Spring application.run sample application.class. Then we also need some configuration. So since we will be using Postgres, I'll need, in this case, I choose to create a Spring configuration where I will define my data source by hand. Of course, you can do this in a lot of other ways, but for the purposes of the demo, I will do it like that. And here I want to define a bean public data source. Let's give it the bean annotation and return. No, I need a new simple data source. This is the Postgres data source. We need to provide it with the URL from our database, and this is this one. Of course, the user and the password. Voila. Now we have the data source up and running. Voila. Okay, now we want to create a service which will run in the background, and a controller where a REST controller which will call, and that will then schedule the actual background job. So I'm going to create a new class, service in this case, sample service. And this is of course a service. And here we will have a method. This will be your typical business logic, your domain. If you follow the DDD concepts, this is where your actual heavy lifting would happen. And of course, we can give parameters. This can be any object. This can, as long as the JSON libraries can serialize it, you can pass it along also here. So it can even be some domain object or a value object. And I will say a typical hello world example in this case. And since it's a long running job, let's make it sleep a little bit. And even if your services throw exceptions, JobRunner will not, they don't mind. So you can throw any exception, whether it's a runtime exception or not. Then we need another class for our REST layer. So in this case, it will be sample controller. And this is a REST controller. Let's set up a constructor. To schedule our job, we will use the job scheduler like you saw before. And of course, we will need our service where we want to schedule the long running job. So now that we have them available, we can create the actual REST resources. Let's call it enqueue1 job. And also here we can pass request parameters, for example. Let's give it, for example, name is name. Let's also give it a default value, world. And now how to call JobRunner? Well, job scheduler.enqueue, and then we say a lambda. And we can just call do long running task, and we pass the name parameter. Voila. So by default, we included the Spring, the JobRunner Spring Boot starter, and by default, it will not start the background job server nor the dashboard. So just to be on the safe side, if you want to do that, you need to create a Spring Boot property file, which is application.properties. And here we can just say there is code completion. So we want to enable the dashboard. And we also want to enable the background server in this case, because I'm getting out of time. Let's try and see whether all has worked well. I still need to start the Postgres via a Docker container. And if I run my application, it's building. I hope it starts soon. Then, yeah, what will happen? There it is. We see migrations going on. So JobRunner automatically creates all the necessary tables and databases. We see that the dashboard has started on port 8000. So if we go to the dashboard, then we see our dashboard. We have one background shop server available, and of course, no jobs. Let me schedule a job. So we go to our Spring stuff, which is running on port 8080. And if I remember correctly, it's enqueue job. One job enqueued. Let's enqueue a couple of them. And normally we see there are 7 jobs enqueued, and soon, yeah, they're already in processing. So now JobRunner is processing them, and they will soon be succeeded. So if you have a lot of jobs to do, you can just create, spin up a lot of other background shop servers, and they will all share the work. So it's ideal for a Kubernetes environment, and yeah, everything is included, monitoring and stuff like that. So that's about it.